Okay, so good morning, everybody. Welcome to GSE, if this is your first session this morning. Same procedure as always. You are on mute, so any questions that you've got, please put them in the chat, and I can pass them to oh, what's his name?
Ash.
I can pass them to Ash during the session if it's appropriate. Otherwise, we can save them up and ask them at the end. I guess without further ado, oh, don't forget the feedback at the end. So without further ado, I'll hand you over to Ashmay.
Thank you, Anna. It's not that you've not been my manager for many years before.
I haven't.
No.
So I'm allowed to forget who you are.
You forget who I am now. Right. Hi there. My name's Ash Mahay. I'm one of the offering managers for the Omegamon portfolio product suite. And today we're going to look at how to diagnose and solve zOS application issues with APIs and subsystems, specifically around Java monitoring and zOS Connect monitoring. Let's go to the next slide. So we're going to learn about the IBM solution. This is Omegamon for JVM, how you can get great insights into critical resources. Also, like I mentioned, zOS Connect, specifically API monitoring, and how that will impact your service. So the agenda today is a brief overview of what challenges a hybrid cloud monitoring environment, just a brief overview of what how Java works or fits in on Z, and look at the API revolution or revolution, whichever way they want to call it. And then we'll look at how monitoring hybrid clouds with IBM Z Omegamon for JVM. We're going to really go into typical scenarios with the Omegamon for JVM as the views, just to explain the scenario. So we're going to look at how you can manage Heap, look at the garbage collection, look at all the JVMs that are active. They could be in the subsystem, they could be a standalone, there could be a batch job, how you can see these or visualize these side by side without any instrumentation. And then we'll look at specifically about API monitoring. So zOS Connect Enterprise Edition, I've got that wrong. zOS Connect EE rather than EE Connect. API performance, and then performance improvements overall with the monitoring. I'm going to mention about Z Trial. Now that's available to everyone for free, and I'll give you a link. I'll provide a link for that at the end. And then any additional resources you may need to, if you want to go and play later on and have a look at more product details. Okay, so we'll go straight in. So technologies like Java underpin application transformation and connectivity across the enterprise. I mean, zOS is rapidly becoming one of the optimal places to run Java workloads. Many customers are using this today. I've worked with many customers in my lab services role in the past, where Java could be standalone or in batch, or could be in JSOS. These Java workloads are running on zOS, and they're very active today. Virtually all major zOS systems now have some component of Java. You've got subsystems like Kix, IMS, DB2, they have Java that can run within them. So monitoring those or capturing those is going to be important, because you don't really want to have a dark or avoid blind spots in your monitoring, but overall in your IT operations bridge. So IBM Java 8 implementation with Z architecture, so even if we look at the current architecture, Z15 provides significant performance throughput improvements. And so the ability to optimize performance, manage subsystem performance is key for zOS success, and Java is part of this. So maybe some of you already been working with APIs, as I mentioned about zOS Connect Enterprise Edition. We're living through an API revolution, as I've been told, from Alexa to Apple Pay. I mean, you got open banking, and you got vehicle lookup, smart meters, and connected cars. All of these will have some form of APIs behind them. So APIs are changing the way that we do business. And you've probably just seen through your apps on phones. And this is where key transformation digital economy is coming through, where we're looking at smartphones, digital devices, connected Internet of Things, as we've been told, that's going to exponentially increase to billions of devices per year. Connected to the internet. Enterprises across the industry are seeing the opportunity to change the way they interact with the customers. And this is a key where, like I said, with smart devices. So they're looking at digital transformation and looking at how they can implement a hybrid application. So if we look at APIs today, so according to market analysts, there's about 1,000 enterprises will need to integrate or need integration with API enablement on Z in the next few years. And we're seeing the results of this in the market activity around zOS Connect Enterprise Edition. So we can see that for some stats here, 60% of enterprises place APIs as being critical to their Z integration strategy. I mean, 10 of the top 20 world's banks already using zOS Connect Enterprise Edition, and there are some customers who are reaching upwards 150 million API requests per day through zOS Connect Enterprise Edition. So these aren't small numbers, and the customers are using this and interacting with the mainframe for the APIs. So that's important. But if you look at how this plays a role in a hybrid environment. So since we're talking about hybrid cloud and how IBM Z is a critical part of it, it needs to be understood how these and you shouldn't look at IBM Z in a vacuum. To understand today's more complex hybrid cloud applications, you must see impacts to both IBM Z and distributed platform resources that underpin and connect the hybrid cloud. Oops, wrong slide. JVMs such as zOS Connect Enterprise Edition are now business critical links to the mainframe. Therefore, monitoring zOS Connect Enterprise Edition JVMs and the API requests is key to avoiding major blind spots in between applications, database, and middleware. IBM Z monitoring, or the Omegamon family, provides this capability. So looking at hybrid cloud applications, so here I'm going to introduce you to briefly Omegamon for JVM. Now you may see there's two products listed here. I'll explain the second one later on in the next slide. But IBM Z monitoring, IBM Z Omegamon for JVM is IBM's solution to monitor all online Java workloads on zOS across the enterprise. Excuse me. The product provides insights into many important Java items, which will support IT operations application owners to manage the online services on zOS. Out of the box, as you see there, the product auto discovers online JVMs regardless of application or subsystems running in it. So if it's kicks IMS, regardless, as you can see on the left hand side, you got JVMs that run in those subsystems. They will be auto discovered, which means you don't have to instrument the JVMs with the product, just to auto discover. So you'll see them online, and we've seen customers who are actually unaware that they're running Java workloads in production or specific Java workloads in production because they've not been monitoring them. So just installing the Omegamon JVM agent and starting it, it auto discovers all of these JVMs. So customers saw the value of that straight away there. When compared to other Java monitorings, I mean, we did say for data collection, the data collection is lightweight and easy to configure. So we don't require, and this is key here, we don't require bytecode injection or complex instrumentations to monitor your Java workloads. This means value is achieved quickly and with low overhead. We don't need to have JMX ports open, and etc. So while Java monitoring is covered in many tools, IBM Z Omegamon for JVM has been developed with zOS operations teams in mind, and has key KPIs that affect zOS users specifically, such as you can see, tracking zips offload. That's important for Z customers, and native memory as well. Native memory consumed by the JVM itself or the virtual machine within a language environment enclave is also monitored. While Omegamon for JVM is a general monitor for all JVMs or Java, this product also includes specific monitoring for zOS Connect resources, as I said, and we'll go into more details further on. And more importantly, the zOS Connect APIs that are within that. The delivery options, you do get an option to install it, obtain Omegamon for JVM through a standalone PID or standalone offering, or you can buy this part of a obtain it through a suite. Um, Now, the runtime edition, as I mentioned, IBM Z Omegamon runtime edition, there are requirements for some customers who really just want to monitor a subset of the JVMs in their production or maybe in their test environment. So you have this ability, you have the runtime edition offering that allows you to just purchase simultaneous instances, i.e. just the number of instances you want to monitor as opposed to the whole infrastructure or rather your whole enterprise pricing model. And that adds more flexibility, and similar to how zOS Connect pricing model works, you can purchase either simultaneous instances or you can purchase through zOS based monitor as well. Now, what I'd like to do is just talk to you about some of the feature updates that have occurred since we released Omegamon JVM. Now, we had released 5.4. In that, we provided advanced monitoring for zOS Connect APIs. In this case now, we recorded every API request that runs through zOS Connect. We break down the API response time from zOS Connect time and system of record time. That's key. So you can actually see if the slow response time is either in zOS Connect or part of the system of record. Excuse me. And we actually provide or expose the service provider details. So we tell you now if it's Kix, which Kix program was called or consumed, and or which IMS region that your transaction ID that's being called at the system of record. With version 5.5, this was released in first quarter 2020. We enhanced the native memory monitoring. We provide 24-bit and 64-bit native memory monitoring as well. Before it was just 31-bit. We provide supplementary API visualization, and we'll show you some of those screens later on. We provide a list of completed tasks. So now you'll be able to see if jobs that have stopped or have been cancelled. You can see if they were actually due to a memory issue or if it was just stopped by a user or so forth. You can go back in history in that. We improved collector performance, and I'll give you some indications what they were. And as I mentioned earlier, we have a new pricing option. So runtime edition is available if you want to start small and grow and add as you grow your JVM estate. Now, next, what we do have new updates. I mean, we're in a continuous delivery mode, so further updates are planned for Omegamon for JVM 5.5, and you will probably see some more PTFs APAs coming out in the future. Um, so what we'd like to do in this, on the next few slides at least, look at typical scenarios where IBM Z Omegamon for JVM can help. So in this case, we're going to look at understand which workloads are running, how you can see them, what's the visibility, and how you can auto discover them. Then we'll look at monitoring service levels, so which patches or which JVM versions are running or Java versions are running in your environment, how you can quickly identify those. Of course, if you're interested in compliance, if the Java versions aren't approved, you want to catch those JVMs that are running the old Java versions and then quickly patch them, or at least update them, replace them. Then we'll go into scenarios where we look at memory usage. Now, this is heap occupancy, for example. Then we'll look at how you can monitor native memory, and that's also key, especially on Z. How you look at the overall memory and how you monitor that. And then we'll look at garbage collection, how garbage collection can affect your performance of your applications, or at least your requests. And we'll see an example how you can catch a Java garbage collection issue. And then we'll look at other performance issues, like are there any lock contentions, are threads blocked? Could that be a performance issue, i.e. is your application request slow because of there's a acquired lock that needs to be freed. Then we'll look at API performance, and this is where we'll spend a bit more time about how you can look at or show you screens about on zOS Connect times, API request times, overall, breaking them down to system of record times as well. Then we'll look at performance history. So we can show you that with the enhancement of 5.5, you can go back in time, look at history reports, see which JVMs were running, if they're especially on a weekend where they're cancelled, and you'll be able to catch those as well. Each metric is available that you see can be alerted on. So if you want to catch alerts for any of these issues or scenarios, you can do that as well. So understanding the workload. So how do you know how much Java you're running? And you want to see all of your Java JVMs running that are currently online. So with Omegamon for JVM, you can quickly identify those just by starting the agent without instrumentations. So as long as the JVM agent is active, it will auto discover, all, like I said earlier, all of the JVMs, regardless of the subsystem time. You will get details about the job name and the subsystem type and the basic details about the Java, i.e. which Java version has been allocated, or at least it's running. And so in this screen, we'll see that we at the bottom, actually it's split up in two. So in the bottom screen, you'll see all of the JVMs that have been discovered. They're not monitored because they're not being the Java agent has been enabled, or Omegamon JVM agent has been enabled. But at least, like you can see an example here, you see the job name, what subsystem type it is, the Java home, and the Java version. So you can quickly identify, even just by the uh, bottom screen here, or table, you can see that the subsystems that are active. If you then you want to choose, you may want to choose to monitor those JVMs specifically, or set to those JVMs specifically. Then you can just enable the Omegamon JVM agent in those JVMs that you want to monitor, and then those will be monitored, and they will be switched or placed in the top rows or top table here. So at the top, you can see that there are about 6, 7 JVMs that are instrumented with the Java agent, and you can see there's zOS Connect, there's Urban Code, types of JVM standalone, there's Liberty, there's no DM, there's an IMS JVM. So we catch those and we can monitor all of those. Okay. So we do have a graphical user interface. I mean, most of the screenshots I provide will be on the E3070 UI. However, we do have a graphical user interface, which is called a Tivoli Enterprise Portal. And here's an example where similarly, you'll see the JVMs that are discovered and which are being monitored by the Omegamon JVM agent. So you'll see them here, and this is highly customizable. If you're used to Tivoli Enterprise Portal, you can continue to use that, or some customers will prefer the 3070 UI, and you can also use that. So the single source of truth, you still get the same data from the single agent, but you can display it in different user interfaces. Okay. So here you can see, like I said, we can see we can visually see the JVMs that have been discovered by the agent. Now let's look at scenarios. So we need to show that the Java levels are being used, are up to date and are compliant. So how can you do that? If you've got hundreds of JVMs, you want to be going and looking at each JVM one by one and looking at configuration files, what's configured, what Java version is used for each JVM. That could be time consuming. So what you can do is set up a situation or an event. So you can use in this case, we're using the TEP interface. We can create a situation to go and look at all of your JVMs in your enterprise and just look for a specific version if you like. So in this case, we're looking for all the JVMs that are running, that are configured with version 1.7, and we'll want a warning when that occurs. So as soon as you create the situation, you enable it, within seconds, and literally would it be in seconds, you will find out, or you will be returned a list of all of the JVMs that are running Java version 1.7, and you would not just be told which JVM it is, you'll be told which LPAR it's on and the job name of that JVM. So there you can quickly go and inform your application teams and say, right, you need to update that, or your WAS teams to update the Java version to the latest version. So here you can see quickly the situation was tripped, and you can analyze the data straight away, and it's in seconds. It doesn't take too long. And now you can analyze 100 JVMs in your whole enterprise within seconds with just one event. So that's how you can quickly identify which JVMs are running a back level Java version, if you like. Similarly, you can identify that it's the same situation. It's available in the enhanced 3070 UI, the graphical the other user interface I was mentioned earlier, we'll tend to use in most of our scenarios going forward. But here you can see the same example. You see that situations fired and the events results are in the screen below. Okay, so now next scenario we're looking at is the memory usage. Now, in this case, how much heap is being used or consumed within your JVM. Now, it's quite important to understand, in general, the JVM itself takes care of its objects that are on memory through garbage collection. But as workloads are added to the JVMs, it's important to continuously, at least to review the Java heap allocations, ensure enough is available to satisfy increased application requests. So in this case, you see here, you got a leaker job name, which the heap occupancy is 66%. So 60% of the heap is actually allocated. Now, we can continuously monitor that with Omegamon for JVM to examine the heap. And of course, you can raise an alert if a heap occupancy is increasing or if it's reached 80% or more. And that's a quick identifier that you may run out of memory. So here, for example, if you want to go drill down, you can look at the leaker job name and look at the history by placing H next to the row. So now we see the history selection, the history summary for the leak application or job name. And you can see over time that going from bottom up, that the heap occupancy has been increasing over time. Now you would expect garbage collection to occur, and you can see that has been occurring, and that's also been increasing, but yet the heap occupancy or the heap allocations has been increasing over time. This could be a quick indicator that you might have a memory leak issue. But if you look at the actual JVM allocations, so you can see that the heap size at the bottom, again, bottom box here, heap data, you can see that the mean heap size is around 45 meg, but the min and max is also adjusted, but you can look at how much nursery memory is being flopped or flipped even, sorry. But the heap occupancy in this case, in this screen, you can see it's about 24%. It's obviously not not 66% as in the previous one, but you can quickly see from this screen what heap occupancy, how much of that is being flipped into into nursery, and what's the average pause times of your garbage collection. We're going to look at this in later screens, what garbage collection does provide you. But what a key attribute to look here is the allocation or the allocation failure count. You can see in the middle there, and that's got a number of 86. Now, allocation failures means that it can't find the object size that it needs in order to grow. And if that occurs, you may find that if you've got a high number of allocation failure count, you may find that your heap is actually not large enough for the workloads that that are running for that JVM. So in that case, you might want to have a look at increasing your heap allocation. So in this screen, you can have a look at what your heap allocation is by default. So this is what's configured in your JVM. In this case, the minimum is 4 meg and the maximum is 128 meg. Nowadays, that's a bit too small. And so customers may want to just increase that, or users, if you talk to the application guys, you might want to increase that allocation to something much higher than that. Even if you increase that, the max heap size, that might be insufficient for the JVM workloads. However, you should be aware that memory leak is in the application could be something real. So even if you increase the heap size, you may end up finding that your heap allocation is still being allocated and your occupancy is increasing, as in this example. So if it's creeping up even after garbage collection, even if you increase the heap size, then you are going to, there's something wrong with the application. That's either it's not freeing the objects, or so you really want to get the application development team involved and say, right, your heap allocation, what's keeping their memory allocated in your JVM. So what you're trying to do is avoid a memory error or JVM a bend or core dump. Okay. So that's memory allocation, but that's within the JVM. How about the native memory? So one thing, as I mentioned earlier, you need to look at not just the general JVM heap itself, but also the native memory. Now, the native memory is the native memory is the heap or the memory allocated outside the JVM. So this is the overall memory outside of JVM, known as what we say native memory. Before increasing the JVM heap size, you need to ensure that there's enough native memory available for the JVM heap to extend into above and below the line. So what we provide with native memory usage is the heap allocations, the extended region size, or how much is free. And you can see here in the example screenshot on the right that the 64-bit memory above the bar, which is 2 GB bar, how much is free. I mean, okay, that's saying 1% free. So if that's the issue, then even if you increase the memory heap size, you're probably going to have an out of memory condition. So you want to be able to monitor both the JVM heap itself, but also the native memory heap alongside. So with alerting situations, we provide out of the box. You can do that today without having to watch the screens. Okay, so that's native memory and that's heap, but garbage collection, as I mentioned earlier, that could also cause poor performance of your application. So in this example, is it garbage collection where that's causing the delay? Now, garbage collection has improved, as it says here, over this recently in the last releases of Java. However, you can still have Java issues, or at least poor performance issues, if they're insufficient heap allocation, which we saw earlier or a poorly written application. Now, some of the symptoms you might see is excessive number of garbage collection events occurring within a given time period. What that means is that if your heap allocation is insufficient, you're going to get an increased number of garbage collection. Garbage collection is clearing out memory unreferenced objects, and if that occurring more often, you're going to have performance degradation at some point. High heap occupancy even after garbage collection, as I showed you the screenshot. Even if your garbage collection runs quite often, your heap might be still increasing, or your occupancy might be still increasing, which could be an indication of memory leak. So that's also worth keeping an eye on. Long pause times when garbage collection event is occurring. So when garbage collection occurs, although it depends if you're using pauseless, your JVM will be paused as that garbage collection is being carried out. So be careful if there's long pause times, that can affect your application performance as well. And of course, if a system GC event is occurring, i.e. your application written to do frequent system GCs, that also can impact the number of garbage collections that are occurring on your JVM, in your JVM rather. So monitoring garbage collection is key also for good performance or management of your application. So like I said earlier, garbage collecting, it removes unreferenced objects. As objects allocated in memory, usually goes into your nursery, and this is GenCon. Then at some point, garbage collection runs, and those objects still referenced could be placed into your tenured region in your memory. So that occurs with over time, and that's managed by the JVM itself. Like as I mentioned earlier, so object allocation failures can force a garbage collection because it needs to allocate memory. So if there's an insufficient memory in nursery, it will try and force a garbage collection to free up space so you can use that memory for your requests. And as I mentioned, programmatically requesting system GC calls, that generally doesn't occur nowadays, but some old programs may have system GC, so we need to ensure that those are captured as well. Now, there's 4 types of algorithms or policies, we call them, in garbage collection. So the most commonly used is GenCon, and that's configured at your JVM startup. And in this example, you see there'll be a nursery and tenured allocation for your memory. Okay. Okay, so how do you monitor your garbage collection? So it's a similar screen to your heap occupancy, but this time now we can see the GCs per minute. If there are 32 garbage collections per minute, that's 1 every 2 seconds. That's quite often. And then the hope I got maths right. And then you got time paused, although it's 0.14%, that could increase. So time pause means that your application is paused, or there's a delay in your application because of garbage collection. Okay, so keep an eye on these parameters. Statistics are very important. So if you look at the history again, similar report as before, but this time you can see that the number of GCs per minute are increasing. They were 11 or 12, 11 and a half per minute, and now we're going up to 32 per minute. But the pause time is slightly also increasing, and that could be impacting your overall application performance. So keep an eye on these, monitor these with situations, will give you indication of application performance issues early on as that grow, as occupancy and garbage collection times increase. Okay. So in the next slide here is the lock and threads. So we mentioned heap allocations, garbage collection, performance, etc. Now, it could, if you find that you're having a performance issue again with application performance, and GC is fine, and garbage collection numbers are fine, and your heap allocation, native memory is fine, it could be that there's issues with the locks, or there might be threads blocked. So here in this screen, so if there are no GC issues, perhaps the threads or even are being blocked for excessive period of time, or locks within the JVM being held for long periods, causing an application to wait for the monitor to yield. If high value is found here, the application owner can be alerted, and adjustments for the JVM environment could be made. So in this screenshot here, we can observe multiple attributes which may highlight potential performance issues. For example, object locks missed. This is locks missed percent, and threads that are blocked by another thread block, which are thread blocked column here. And so we're going to in each one of these individually. Sorry, I should mention here that if a threshold's breached, you can see the eye catchers, the actual the metrics are highlighted in red or yellow, depending on the thresholds. So in this case, you could see that the excessive, too many locks and too many threads blocked, in this case, 9 blocked threads. You might want to investigate those further. So average lock time as well, hold time, you can see that's quite excessive. And that could be an indicator of why your application is running slow. So in this screen, you can see that we could statistics on objects being locked by threads. This can be indicative of application configuration issues. So as highlighted here, if there's a missed percent is high, and you can create a situation for this, you want to make sure your application teams are aware of this as well. In the next screen here, so if we switch to the threads statistics workspace, we can see that all the JVM threads, all active JVM threads are listed. You can sort the status. You can sort the status and look at search for any blocked threads. Here, as you can see, there are multiple blocked threads. You can identify which are waiting, and also you'll be notified which objects are being blocked by. So in this case, the contending thread is query 12, that's holding the lock. And so you want to be able to understand what query 12 is doing. Select query 12, and you can see which object it's holding on to as well. But one thing to also note is here, you got CPU time deltas. So this tells you if that CPU time for that thread is increasing or has increased and it's quite excessive, it could indicate that there's a thread that's looping. So in that case, you want to be able to cancel that thread at some point, or at least, or it could be that you're going to end up having to cancel the request. Worst case, cancel the JVM, which you don't really want to do. So you want to capture these early on. Block threads, you can again open a situation, create a situation to manage that, as well as the CPU consumption of a thread as well. Be alerted early on. And in the next screen, we're talking about CPU. So let's switch to another scenario. So if a CPU, you want to manage and monitor the CPU of a JVM, you can go to this you can use the tool to do that as well. So lead us through overall, you can look at the JVM CPU consumed by the JVM. The CPU statistics workspace shows you the CPU consumption of the address space, including zip offloading, as well as zip eligible work that was not offloaded. And what does that mean? I'll show you in the next. You can see here in the resource constrained environment, CPU management will be important. So you want to watch out for zip eligible workload that is running on general CP. So in this case, you can see there's a in the bottom screen. In fact, you can see the zip time. You can see there's a zip on CP time. So that's the key metric to look for. That could indicate that either your zip processor is missing, or it's absent, or there's lack of capacity overall on your zip processor. So here you can indicate this. Of course, if it's running on CP, you're contending with other workloads. So ensure that if you're using zip and you want to use more zip for your applications, you can monitor those as well and ensure that through the situation alerts. Okay. Okay, so we did add with the Omegamon's JVM 5.5 completed JVM history. So we said it was batch monitoring, or rather batch history, but actually it's for any JVM that's running or has completed on in your enterprise. So Omegamon for JVM now stores a summary of all of the JVMs that are currently not running, i.e. have they been stopped in the past. We store them in our history data sets, the persistent data store. You would need to enable jvm.heap, near-term history rather. It must be enabled, and the documentation tells you how to do that. If you're aware of the Tivoli data warehouse, how those options work. We collect okay, the period covered is determined by the PDS data sets. So if they're allocated small, then your history reports will be small as well. So it depends how big the PDS data set is and how often you create or collect the history. That also affects your affects the period that's covered in your history reports. So if you collect less often, or your PDS data sets are larger, you can have more rows in your reports as well. Okay. So here's an example of a performance report. So you can see that these are the job names that completed. You got the PID names and when the start times, sample count. So you could have had multiple job names that have been run on that LPAR or LPARs. So in the sample count is an example where you've got about 30 in the top row. If you look at the Liberty one, zOS Connect, there've been 30 counts of that. So there's been 30 instances of this job being run over the past days or hours, and you'll get a summary of the heap sizes used, the garbage collection, and so on. And this gives you a summary, and you can quickly see at a glance the metrics about your JVMs that have completed over time. Okay. A similar report is available in the TEP, and you can see here, as before, you can see the counts and the overall performance of that task that is completed. Before I go into API monitoring, are there any questions, Anna? Hello?
No questions in the chat. Sorry.
Okay.
Sorry, the list of participants was so long that I didn't have any space for my chat screen.
Okay, cool. Right. So in the next few slides, we're going to go. We're going to look at zOS Connect Enterprise Edition API performance metrics. Now, as I mentioned earlier, JVMs such as zOS Connect Enterprise Edition APIs are now business critical links to the mainframe. Therefore, monitoring zOS Connect JVMs overall and the API requests is key to avoiding major blind spots. It is important to be alerted to poor API and service response times to manage varying workloads before application owners raise complaints. So in this case, you could see that actually ZOS, you may be aware that ZOS Connect actually can, and some instances I've seen customers running JVM, ZOS Connect JVMs within the Kix region itself rather than standalone. So bear that in mind, where if you want to monitor JVMs or ZOS Connect APIs, they could reside in the subsystems directly as well, which of course we capture with the Omegamon agent as well. So if you could get reports that are coming in that there's a slow response or API response, how can you identify which APIs are affected? Okay, so if you look at this screen here, so this was provided with IBM Z Omegamon JVM version 5.5. This is an API enterprise summary workspace. It's a useful summary workspace because you can see quickly an overview of the APIs executing across the enterprise. Now, this is not just per JVM. This is across the enterprise. We didn't have this until 5.5. As shown on the screen, multiple key metrics are listed and automatically highlighted when thresholds are breached. In this case, we've got error counts for 2 API requests. One's a get, one's a post. And so you want to be able to at least drill down further to understand what the API was doing. Now note, it's an API, it's an error count, so you can capture, and you'll hear me say this over time, you can capture this with a situation as well. So again, unattended works monitoring, you can be informed, and then you can drill down to root cause the issue. Okay. So let's have a look at the scenario then. So we've got an issue, an API request. We know it's an zOS Connect API. So you drill down, press put by entering Z next to the job name, and you list all of the APIs, summary of the APIs even in that JVM. So in this case, we can see the catalog V1 get has a average response time of 10 seconds. And the response time max is 10 seconds. And if you look at the table columns, you can see how much of that was spent in zOS Connect, how much of that was spent in the system of record. And system of record is effectively the subsystem that is the provider of that service. So zOS Connect goes to Kix or IMS, system of record will be Kix or IMS. Okay, so here, so if you want to now have a look at how the instances of catalog V10 or the get method, you can select that row, and here you see a full list of the instances. Now, with Omegamon JVM, Omegamon for JVM even, we capture every completed API request that has gone through that JVM or the JVMs that we monitor. So in this case, you will see every single one listed up to a range of, I think, 9,000 and then, or 2,000, and then you can increase that as well. So here you can see that the full list of the requests, the get requests, as I mentioned earlier, for catalog V10. Now note at the top, you can, because if this list is too long, it could be thousands, it could be 10,000 rows, depending the how many API requests are going through that JVM at the time. So you can use a zoom filter, i.e. you can limit the time filter to the time when you believe that API request was, or when performance issues arose. So you can say the last 5 minutes, or you can say set a time date range, and this list underneath will be condensed, and only those APIs within that time frame will be shown. And here you could, like I said, we could see all of the APIs that have completed through that JVM, zOS Connect JVM. Each column of the here you can see are sortable. So if you want to look at total request time, or if you want to be able to look at just the zOS Connect time, which APIs are taking long in zOS Connect and equally in service in the system of record, you can do that by sorting. Now, if once you've sorted that, you can actually drill down and select the one that's performing badly. And from that, you can see the zOS Connect request details. In this screen, you really have all you need to debug your issue. So in this case, what we can see that the Kix system of record timed out. How do we know that? Because we see at the bottom, or actually in the middle, the system of record response time took 30 seconds. Overall total response time for the API took 30 seconds. So it was predominantly in the Kix region itself. We know which KICS region there is with the SOR ID, and we know which program was used and the transaction with the SOR reference or resource, sorry. So you got MZP0 and you've got DFH0XCMN. So you know the program, the KICS region, the KICS transaction ID, and and uh, the HTTP error. So you can see that the HTTP error code was 503, which indicates the service is unavailable. So you got, I think all you need to go to the KICS SME and say, right, can you please have a look at this KICS region and so on, and they should be able to resolve that. It could be the transaction ID stopped, it could be the KICS region is unavailable. At least the SMEs can help you there, or the IT operations team themselves. They'll be able to see that with the Omegamon for KICS monitoring tools that we don't cover here. But you can see then, you can then quickly be alerted on if it's a transaction ID that stopped and so on. So here, just from this screen, 3 steps. You can do it actually with 2 steps. In fact, you can set up a situation, just say, give me an error when the HTTP code is not equal to 200, for example. You can get an event for that, or you can get an event for just when give me total response time is greater than 5 seconds, for example. If you expect your response times generally to be within 5 seconds or 1 second or 2 seconds, you can set the events or situations to capture those anomalies. But also one thing to note here is you also get the request or the payload length and the payload response length. So the request sent 56 bytes, 2 KICS, but we got 0 back. Another indicator that there's a KICS issue. Okay, so if the in some cases you may find that request length is 56 going out in to KICS, but 300 coming back. If that's a normal number, the length is fine, great. If not, you can set up an alert to manage that as well. We do provide you the user ID the API request came from, and also the map to user ID, the RACF map to user ID that is being used for the system of record interaction. We provide you both of those, not displayed, but at the bottom, but you at least get the user ID, what the non-RACF map to user ID in this screenshot. And you can see it's an API and it was a post in this case and a port number. Okay. Okay, so in some cases, so the SME, the subsystem SME may want to view the APIs, which APIs are supported by a particular system, a system of record or a service. You can use the tabs provided here. So we looked at API name, but you can look at, we've provided additional tabs where we sort by context. So service, SOID, reference, and resource name. Here you can see, right, so if you want to look at system or record ID, you can look at which KICS region that is being used. So in this case, it's the applet of the KICS region, but you can sort by KICS region in that case. Also, you can look at the reference that's configured within the server.xml if you want to look at the reference ID. So I should have mentioned the services as the application or the connection is configured to the system of record. But also you can look at the resource tab here, and this is where you want to be able to monitor possibly the transaction ID and the program that's being called by the API request. So you can look at the context as you wish, depending on your role, of course. Any questions before I continue? Anna?
You didn't see me shaking my head? There's a no.
There's no, I can't see you.
Okay. No questions.
Okay, cool. All right, so got just a couple of more slides now. So as I mentioned earlier, we did increase or improve the performance overall of the collector. Now the collector is part of the Omegamon JVM product. Now in the past, we used the health center to collect some of the details. Now we use JVM TI agent for the garbage collection. So that improves the overall performance when we're looking at garbage collection. One instance is where garbage collection, if it's low usage, i.e. garbage collection occurs maybe once an hour or twice an hour, we don't capture that early on or quickly enough. So now we use a JVM TI agent, which allows us to look at, or at least present the garbage collection details, even if you're using them less frequently. Okay, so that's one improvement you put in place. And also other collector performance improvements: reduce the number of service calls. That usually always helps. Virtual memory statistics now collected on demand rather than being pushed all the time, and that improves the performance overall. And we now collect only locks utilized versus acquired and release. Acquired and release, if that's happening often, that's fine. We don't want to capture those, but it's only when it's utilized. And as you saw in the screenshot earlier, we provide those statistics out of the box. You are, if you like, to play, we do provide a Z trial, so Omegamon JVM and also Service Management Unite. I haven't mentioned that, but Service Management Unite is available, and that provides you Omegamon JVM scenarios as well. So both Omegamon JVM and Service Management Unite are on Z trial. It's free to everyone. You do not need to install Omegamon for JVM in your shop or even SMU. After you just register using the link above, and you get an email that when the environment is ready, and you'll get logon credentials. It's a remote connection to an IBM hosted environment. You do not need to provide a credit card, so keep that in your pocket. And you get 3 days to play with the tools. So in this case, Omegamon JVM, and we've created out-of-the-box scenarios for you, similar to what you've seen before in the slides. And you can try them out yourself. You can play around with other workspaces if you like. Like I said, you have 3 days to play. If you want to have longer, you can just re-register, same trial, and you can just you'll just get another email, and you log on again, and you can continue where you left off. Actually, it will be a new hosted environment, provisioned environment, but you can go back and continue where you left off, or you can just look around and play more. We do provide you, we have written a red paper, Enterprise Java Monitoring with on Z with Omegamon. This gives you more details about Omegamon, Java monitoring, and how you can configure the monitoring on in your environment. It's a red paper, it's a good one. It doesn't need updating, I should have said, and that's the task I need to do. Okay. There are some references available. In fact, there's blogs. We do have a Omegamon Java product homepage. Newsletter, please do register to the newsletter if you want to have regular updates on news about our offerings. We do update them quarterly. So you'll probably find out about new PTFs or APARs that are coming out from the Omegamon product family in the next newsletter. There's also there's a operational excellence workspace as well, or page, which gives you a overview of monitoring and also analytics in Fusion as well. So I do recommend looking at that page as well. My email address is on the bottom left. This time it's readable. So please, if you have any questions, just ping them to me directly, and I'll be happy to help you. That's the last slide. Anna, any questions?
So no actual questions, but some kudos for you. Great information, though lots of it. Lots of it to process. Glad the slides are available for later. I assume you have uploaded them.
Yes.
And Aileen thinks that the video will help too. So many thanks. And for Michael Carey, great information or informative. Oh my goodness, informative presentation. A wealth of experience. Thank you. And from Tim, thanks. Very interesting. If anybody does want to actually say anything out loud, I have given you the power to unmute yourself. Please remember to fill in the feedback for session 3AW. We would like to have Ash back next year and a face-to-face session. So please show your appreciation in the feedback. And also please show your appreciation to the National Health Service by donating a small amount to our charity for this year. You know, you would have bought a raffle ticket strip at the gala dinner. So, you know, think of it that way. And like I said, any questions, please pop them in the chat. Oh, from Patrick to everyone, great presentation, Ash, again. This will help me a lot to implement JVM in the near future. Thanks.
Hey, Patrick. Yes, nice to hear from you. Yeah, give me a shout. You've got my email, I know that, and we can help you get you up and running if need be. As always, open to everyone. Send me an email if you need assistance. If you want to just play, just like I said, use a Z trial. It's there available for free. And any questions, just ping me, and happy to help. It will be my pleasure.
And a question to me, where can you find the video? The video will be available in a week's time. That's because obviously it needs to go for editing and so on, chop off the preambles and anything that occurs after we finished. So the video will be available later and shared with registries, people who registered. Okay. Having a bit of trouble with my English grammar today. So yeah, a few people have left, but not many. So it's still open for you to chat with Ash. I can leave the session open for you know, another 10 minutes or so if anybody wants to just have a chat.
Hi, Ash, this is Patrick.
Hello.
Hi. It's too quiet, so I start talking.
Thank you.
Tomorrow we have a meeting with IBM here in the Netherlands, and we will speak about the Java JVM, and we will look into this one. But we're still at the 5.4 release, so it's in relationship with the zOS Connect. So do we first need to update to 5.5, or we can start and miss some features?
Absolutely, Patrick. You can install 5.4 with the latest APAR, which, as I mentioned, we do provide instance-based monitoring of APIs. I believe you have APIs, so you can get that straight away. So we capture all of the APIs, even with 5.4 in 5.4, and you will see quite a few of those common screens in there in your 5.4 environment. It's the summary workspace that for API summary workspace, you don't catch that until you're on 5.5 and other like batch workspaces or completed task workspaces. But those are in 5.5. It shouldn't be too difficult for you to move from 5.4 to 5.5 after you've got 5.4 running.
Yeah. At the moment, we're at monitoring suite. I don't know the name exactly, but I asked to install 5.5 in our SMP environment, but IBM sent me a whole new suite. Is it possible to only select 5.5?
I believe so. You can just select the one agent from that suite that you were provided. So you should be able to do that. Yes. Ping me, catch me offline, and we can. I can ask.
Yeah, that's okay. But I will start with 5.4.
Okay.
And perhaps in a month or so, I will contact you.
Yeah, sure. When you get 5.4 running, make sure, like I said, you get the latest APAR. I don't have it to mind. I'll send you the APAR number in your email response, which is the SPE1 or special program or small programming enhancement. Don't ask me why it's called SPE1, but it's SPE1 that was delivered.
Okay, presentation. Ash.
Yeah. Sorry?
It's not in your presentation.
No, I was concentrating on 5.5, but I can provide you that. I'll send you that email.
Oh, that's okay. Okay. Yeah. Thank you. Thank you very much again.
Welcome.
Enjoyed it.
Excellent. Thank you.
Speak to you later. Thank you.
Yeah. Cheers, Patrick.
Okay. If if no one else has, yeah, everybody's just dropping out now. So if nobody else has any questions, we will end the session. And again, thanks everybody for attending, and especially Ash for presenting.
Welcome.